Welcome, ladies and gentlemen, to our Sciences film practical of friction. Now, of course, friction is the force that opposes motion when two objects move against each other. And we're going to be looking at three features in relation to friction. One is the surface texture, so how rough the surface is. The other is surface area, how much of it is in contact. And then the load, which is how much weight is on top of it. As usual, there will be a practical write-up come up on the screen, so if you'd like to pause this and then switch it on when you are ready to go. Okay, ladies and gentlemen. Now, in order to measure force, what we're going to use is one of these things which is called a spring balance, or a Newton spring balance. You can see that has a spring there. We put the load there, and then we measure the resultant force down this particular scale here. And obviously, in this case, we're using newtons because newtons is the measure of force. When you get this, you've always got to adjust it and calibrate it up to 0, so your results are accurate. So you basically screw this on this screw up the top here, up or down, in order for it to get 0. So that's 0 there as we speak. Now, here's our jarrah block that we're going to use to drag across our surface. So we're looking at limiting friction, which is the friction or the force required to overcome friction from being stationary. And we simply pull it along and we end up with about 4 newtons of force. Obviously what happens is once we have the object moving, then the friction becomes a little bit less, but we're recording the friction that it takes to start it moving. So about 4 newtons with the rubber mat. We change over to sandpaper, pretty rough looking sandpaper, and we go around about 5 newtons of force there. And you can see it's actually pretty difficult to try and get it to move. Over here with our glass, that's at about 1.5, so that's actually quite easy. So in relation to surface texture, and in terms of the roughness, this sandpaper is the roughest, cork mat is second, and then we've got our glass. So our surface texture of the rubber mat's 4, 5 for sandpaper, and 1.5 for glass. Now, in terms of load and surface area, okay, I'm just going to put those ones aside, and I'm just going to use the bench, because the bench, again, as long as we use the same bench for each time, that'll be sufficient. So in terms of surface area, we calculate surface area by the length times the width, okay, and on your write-up it's actually got those numbers there. You can actually take this a step further and graph it if you wish. So we're going to go on this surface, this surface, and the surface around the side here that we're going to do. So let's have a look at this one here. Okay, so again we're overcoming the friction, and we're at about 2.2 newtons of force. Let's transfer it now up to on its side, and let's go through the same again, and again we're at about 2.2, and then we go this way, and then we need to go this way again, and we pull it, and we're at about 2.2 again. So all of the three surfaces actually have about the same amount of friction. Now, in terms of load, we're going to go back to the standard on its side, and we're going to go our weight added onto the piece of wood. Now, we know that just dragging it by itself like that gives us about 2.2. So what we're then going to do is we're going to increase it up a little bit. So we're going to put a weight on, and we get down to about 3.5 with that one, with 1 kilogram on, and adding another kilogram on, well, that's in excess of 5. So because it's right at the bottom of our chart there, so that's more than 5. So you can see 2.2 without the weight on, 3.5, and then over 5 for the total load of 2 kilograms. Again, please complete your write-up. If there's any questions or concerns that you have, please go and see your contact teacher, and have yourself a lovely day.